Hi there, this is video U414. It is the third part of the ambiguous case. We had the introduction, and then the first video showed what happens when the line is too short and you get no solution. This video is going to show you how it looks when you have one solution or two solutions and how to fix that. All right, so one solution. What is going to be the shortest distance from B to the line at the bottom? Well, we kind of already showed you that in the previous video. It's going to be a nice straight line. So really just find my clear ruler. All right. So the shortest distance between two things is a straight line, which means this becomes a 90-degree angle. Oh, let's answer the next question. Well, at this point, if you know that's a 90-degree angle, I guess finding angle C isn't very challenging because that's angle C. But let's do it mathematically. So A, and this is little a, and this is little c, and this is B down there. So A is 3.21 centimeters, C is 5, A is 40. This one I know. So A over sine A, going to be C over sine C. Because I'm looking for angle C, even though I know it's 90. We're just going to do the math anyway. 3.21 over sine 40 is just 5 over sine C. Let's get rid of that sign. .21. Oops, my bad. Try again. 40 sine 0.646428. Cross multiply. So I've got the 64 on my calculator, so I'm going to multiply it by 5. Oop. And I get 3.2139 is 3.21 sine C. Divided by 3.21. Guess I should have carried a few more decimal places because I needed that to work out exactly to 1. Because now if I do second and sine, it gives me error. But I'm going to tell you, it's supposed to be 1. Divide, whoops, square. 1, 90 degrees. So we'll just round that. We'll cheat. We're going to round that to that much. So C, 90 degrees. That's a rounding error issue. I'd make it really perfect. I would have needed to add a few more decimal places there to make this work out. So, but we already knew in step 1 that it was going to be a 90-degree angle. So one solution, you get to use 90 degrees. So technically you could have found, oh, never mind. I was going to say you could find this using the primary trig functions, but you already know it's a 90-degree angle. All right, let's get to this one. Okay, so we got little a, we got little c, and we got little b. And a is 4 centimeters. It's kind of cool because when I was making this up, I didn't do the drawings ahead of time. I just guessed at 4 centimeters, so it worked out that diagram I used in the previous one worked out to be 4 centimeters. All right, so One last time. A over sine A is equal to C over sine Z. A, which is 4 over sine A sine 40, is equal to little c, which is 5 over sine C. 1, 2, 3, and a very low. All right, we're golden. Being that paranoid mathematician, I'm just going to keep working out sine 40 every single time. 0.6428 over sine C. So multiply. So time. Oops, what did I do? Oh my goodness. What have I done? Clear, 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 clear. Times 5. 3.21. 4 sine C. 4, 4. 0.8035, and then go second and sine, and we get 53.4, so 53 degrees. So the 53 degrees, my pictures aren't to scale here, or so that's what you have to watch for. Oopsies. With the ambiguous case. So first of all, you have to be looking for, what are we looking for? You have to be looking for an angle, and you have to be given two sides, and the angle isn't between them. I don't want to say the word, but it's what I remember. So if you have side, side, angle, just double check at the end whether it can be no triangles, one triangle, or it might be two triangles. And whichever depends on the math that you have. And with something like this, it depends on the question. There was one I did previously. It said, and this side, side C, is the longest one. Well, then you know it has to have the biggest angle across from it. If it doesn't say anything, then you can assume it is the smaller of the two. All right, that is it. And I think I'll give you a quick preview. Check it out. That'd be so much more exciting if you could see the top of the screen. Keep going. The next video, we are done with the sine law for a while. We are going to do the cosine law, which is a little longer, but it doesn't have all these crazy variations. So it's pretty cool too. See you soon.